Welcome back to the video lectures on conditions of equilibrium of a floating and submerged body. This is the second part, and in this second part we shall see stability of submerged body. Stability of submerged body. We shall see this head. Here I have drawn a figure. This is the figure of a balloon completely submerged in air. So this is a balloon completely submerged in air. This balloon, let the bottom part be heavier than the top part. Since the bottom part is heavier, the center of gravity will be at lower portion, and let center of buoyancy will be at top portion. So since the weight is concentrated in the bottom part, the center of gravity will be at the bottom and the center of buoyancy will be at top part. Now we all know that through center of gravity weight acts downwards, and through center of buoyancy force of buoyancy acts upwards. Force of buoyancy or buoyant force acts upwards. So this is the first figure. So first figure is a balloon completely submerged in air. We consider air as a fluid, and the weight is concentrated in the lower part. Since the weight is concentrated in the lower part, the center of gravity will be at lower portion or lower part, and the center of buoyancy will be at top part. The center of buoyancy will be at some point, and the center of gravity will be below center of buoyancy. I should have said like that. Since the weight is concentrated at the lower part, center of gravity is at the lower part, and the center of buoyancy is above center of gravity. Now here I am going to give a small tilt to this balloon. So the green arrow marks the angular displacement that we are going to apply. So due to this slight tilt, the first figure will transform to the second figure, this figure. I am going to draw everything there also. Center of gravity, center of buoyancy, weight, force of buoyancy F2, and the angular displacement. So if you look close, you can see that the force of buoyancy, the center of gravity, forms an anti-clockwise moment. I'm going to draw that alone over here. Weight and force of buoyancy or buoyant force. It will be like this, and this will be the angular displacement or the momentum that we have applied. From this figure, the third figure, it is quite obvious that the weight and force of buoyancy constitute a couple, forms a couple that acts in anti-clockwise direction, and is countering the angular momentum and is trying to bring back the balloon to its original position. So when this disturbing displacement or angular displacement is removed, the balloon will return to its original position. Because when we apply this angular displacement, the balloon tilts, the weight and buoyant force, they forms a couple opposing the angular momentum or the momentum caused by the displacement, and it tries to bring back the balloon to its original position. And this is termed as stable equilibrium. So, for a submerged body, if center of buoyancy is above center of gravity, the body will be in stable equilibrium. This is the condition. The body will be in stable equilibrium. I hope that concept is clear. Due to the tilting, due to this angular displacement, a couple is formed by FB and G contracting the moment, the clockwise moment, thus the balloon returns to its original position. So what I'm trying to say is that for a submerged body, if CB is above CG, if center of buoyancy is above center of gravity, the body will be in stable equilibrium. Now we shall see another case. I'm going to draw the very same figure once again. In this figure, everything is same. Here also we have a balloon, but the weight is concentrated on the top part. Therefore, CG will be at top, and CB will be below CG. We have considered that the weight is concentrated at top portion. Therefore, CG will be at top part and CB will be below it. Through CB, center of buoyancy acts, FB, and through CG, weight acts. Once again, we are going to give an angular displacement, and due to this angular displacement, a tilt happens to the initial state of existence. So initially the balloon was straight, can be considered as straight, and due to this angular displacement, the balloon tilts towards right. Now let us draw that also. We have CB, we have CG. Through CB, FB acts, through CG, weight acts, and the angular displacement forms a clockwise moment represented by this green clockwise moment. So if I draw that to the side, this whole situation to the side, I have this is FB, this is weight, and this is the clockwise moment. The green one is the clockwise moment which is coming due to this tilting, due to the angular displacement. So if you look closely, you can say that the FB and W, the force of buoyancy and weight, is causing a clockwise moment in addition to the clockwise moment generated due to tilting. Okay, so the weight and force of buoyancy is making a clockwise moment, and the tilting, the angular displacement, is also causing a clockwise moment. Thus we can say that the body will not return to its original position. The body will not return to its original position, but it moves to a new position. This is termed as unstable equilibrium. So we can write it as, for a submerged body, if CG is above CB, the body will be in unstable equilibrium. Why? Because when the tilting happens, there will be a moment forming between force of buoyancy and weight, and that moment will also be in the same direction as that of the moment caused by tilt. So the whole body rotates and it moves to a new position, moves to a stable condition. So for an unstable condition to happen, the submerged body should have center of gravity above center of buoyancy. Now for neutral equilibrium, center of gravity and center of buoyancy should coincide. Center of buoyancy, center of gravity. When center of buoyancy and center of gravity are the same point, the body will be in neutral equilibrium. And in neutral equilibrium, the tilting or the angular displacement will not have any effect on its position. It will not come back to its original position, nor it will move to a new position. So these are the three equilibrium conditions for a submerged body.